So for this problem, we can do trig substitution. So that's where we take x, right, and set it equal to secant theta. And then we can do the derivative of x, which is dx, and derivative of this, which will be secant theta tan theta d theta. Okay, so now we just plug in. So for example, here we have ln, so x is equal to secant theta. For x squared, right, it'll just be secant theta squared. And then for dx, we have to replace it, so d theta. So dx is equal to this entire expression. So to get dx, we replace it with this entire expression. So now we have our trig substitution, and now what we can do is just simplify some things. So this is a trig identity where you take secant theta squared minus 1 and change it into tan squared theta. And so after that, just square root it, so that'll just be tan theta. And then after that, what we can do is some u substitution. So when we do a u substitution, we can do u is equal to this entire expression, ln secant theta plus tan theta, right? So when we take the derivative of this, it'll be 1 over secant theta plus tan theta multiplied by the derivative, right? So the derivative of secant theta is secant theta tan theta. Derivative of tangent is secant squared theta. So after we have that, what can we do? Well, for the numerator, we can factor out a secant theta. So we'll be left with tan theta plus secant theta, right? Because if we multiply this, secant theta times tan theta will be secant theta tan theta. Secant theta times secant theta will be secant squared theta. So this and this are the same. But notice that since we factored, we can now cancel both of these. So we'll be left with du is equal to secant theta. But we're still not done, right? Because we still have this part. So we can do another thing, which will be dv. So dv is equal to secant theta tan theta d theta, and then v is equal to secant theta. And we had to use v because we already used u. So since we have u and v, we can use uv minus integral of v to u. So for u, what we do is, for u, we have ln secant theta plus tan theta, right? So we take that, and then v is secant theta minus integral of v secant theta, and then du is secant theta d theta, okay? So we can simplify that, make that secant squared theta d theta, and then over here, we can have ln secant theta plus tan theta, secant theta. And so the integral of this, right, integral of secant squared theta is tan theta. And don't forget the plus c. But remember that since we did a trig substitution, we can't leave it in this form. We have to convert it back into x form, right? So how do we do that? Well, we take our original trig substitution, right? We take this substitution of x equals secant theta. So we take x equals secant theta, and I rewrote it so it's you can see it better. So x equals secant theta, but you can rewrite x as x divided by 1, because that means the same thing. But what does this mean, right? So secant theta is the same as 1 over cosine. What is cosine? Cosine is adjacent over hypotenuse, right? So when we have 1 divided by a fraction, we can just flip it and multiply it, right? So it'll be x over 1 is equal to hypotenuse over adjacent. That means the hypotenuse, if we build a triangle, the hypotenuse will be x, right? And the adjacent side, this is the opposite, so the adjacent side will be 1. Now what do we do with this? Well, now since we have two sides of the triangle, we can just use Pythagorean theorem to solve for the last side. So we use Pythagorean theorem to find that this side is square root of x squared minus 1. Now we have everything we need to find the different substitutions. For example, we have secant theta, right? Secant theta is just x, so we can substitute secant theta for x. But we also have a tan theta. What do we do for that? Well, for tan theta, we have tan equals opposite over adjacent. So opposite over adjacent, which is square root of x squared minus 1, divided by 1. So it'll be x squared minus 1, right? So if we have a tan theta, we substitute square root of x squared minus 1. If we have secant theta, right, we do x. So if we have tan theta, we have x squared minus 1. And then finally, plus c. Don't forget the plus c, because that's an easy way to lose points. So I hope all of that helped, and thanks for watching.